Welcome, Math 13 students. I'm going to go ahead and give a short lecture on the parameters of a binomial probability distribution. This will close up the chapter in section 5.2. Then I want to do a little bit of a summary on significant outcomes and the various calculator tools that we have used. All right, so today we're going to work with the parameters of a binomial distribution. I'll remind you a couple of things about vocabulary. Parameters. Those are things like the mean, the standard deviation, and the variance. We use the word parameter when we're talking about a population, and a probability distribution is very much thought of as a population. So, if we do have one of these binomial distributions, and we'll take a look at one in a moment, this is one of the few places our calculator is not much help. We actually need the formulas to find the mean, the standard deviation, and the variance with a binomial distribution. Now, the really nice thing about it is regardless of the number of trials, the formula that we use in each of these instances is really, really straightforward. It is not difficult to use them at all. The only thing that might be puzzling is where are n, where are p, and where are q. So for the mean, p is the probability of success in any one trial, n times p. This is the formula that we use to find the mean with a binomial distribution. The standard deviation is the square root of n times p times q. And I'll remind people that q is equal to 1 minus p. And q being equal to 1 minus p, it's usually easy to find. It's usually not hidden overly much. The variance is just the square, if you will, of the standard deviation, although honestly it goes in the other direction. Sigma squared equals n times p times q. There are some instances where we do expect students to be able to figure out p and q on your own without a lot of help. Let me just give you a couple of those examples so you know what they are. There's a couple of different plays on pretty much the exact example. Probability of a girl, or maybe a boy, in any one birth, 1 out of 2. You're expected to know that about half the babies born are boys and half the babies born are girls. And then we have various plays on this. Probability of a correct guess on a true-false question. You're expected to know that the probability of correct is 1 out of 2. Or, for example, the probability of a heads or perhaps tail in a single flip of a fair coin. And here again, you're supposed to know that the probability of a head is 1 out of 2, 1/2. You can see that these are essentially the same sort of situation with the context giving flavor to the problem. Gender, correct versus incorrect, heads versus tail. So these are some you're supposed to know. One that's not on here, dice. Dice have one of 6 particular outcomes. So for example, the probability of rolling a 2, 1 out of 6. The probability of rolling a 6, 1 out of 6, etc. you're supposed to know those types of things too. Just very, very basic. Other than that, the P and the Q is usually supplied in the problem. In the first case, all these up here, P is 1/2, Q is 1/2, because we know that P and Q have to add to 1. And 1/2 plus 1/2 is 1. So when we're talking about those types of situations, P and Q, 1 out of 2. For dice, P is 1 out of 6, Q, 5 out of 6. And here again, you're expected to know that dice have 6 sides. And if they are fair, they come up with equal likelihood. So in terms of dice, there we go. Other than that, you really can expect the P and the N to be really prominently displayed in any of these types of problems. So let's take a look and see how this works. Now, before I go ahead and show you how this works, I need to set this up. So give me a moment here. All right. So here's my example of working with the probability distributions. So consider, we have 2 ways to find the mean and the standard deviation and the variance. 5.1 gives us list 1 and list 2, and I can use the one variable stats operation to do that calculation. That's one way to go about doing it for the binomial distribution. And it applies for all binomial distributions. So in 5.1, I can put stuff into lists and use the formulas that are built into my calculator. 5.2, I can use the formulas for the mean, standard deviation, and variance. And I'm going to try to convince you that the formulas are really a better way to go about it for a couple of reasons. So I'm going to do a calculation. I guess I'm going to do it twice. And I want to run through the list 1, list 2 approach from 5.1, because that's going to give me a chance to review keystrokes for you guys. And these are very important keystrokes. So let's see. We've got n equals 4 random births. And my random variable x is going to be equal to the number of girls that I might see in this 4 random births. We have a probability distribution here. I can use my binomial PDF 5 distinctly different times to calculate each one of these, although really there's a lot of symmetry, and I probably, kind of that would help me too. So if I am in section 5.1, this is what we have. 5.1 means this is the table that I will put into my calculator. So let me come back over here. Let me share my screen and bring up Mr. Calculator. Where are you? There you are. Sometimes he wanders away. So stat, edit. Oh, look, we've got data in there already. List 1, I have the outcomes, 0, 1, 2, 3, and 4 for the possible number of girls in 4 births. List 2 are the probabilities. So I can pick up stat, calculate. Oh, I don't have my wizard turned on. Let me turn on my wizard. And then I'll do the calculation again with the wizard off, and we'll see that we get the same value in both cases. And here's the weird thing. So list 1 for the values, list 2 for the probabilities, calculate. And here's the really kind of weird part. It really uses that other tool. So I have a mean of 2 and a standard deviation of 1. I could square that to get the variance. 1 times 1 is 1. And again, I will note down here, I've got everything else that I need in terms of my 5-number summary too. So there's my mean, there's my standard deviation, there's my variance. Let me note that over here, and then I'm going to go ahead and take a look at what I've got in terms of my formula. All right, so that's a fine way to go about doing it if you've got a table in front of you that's easily placed into your calculator. Get you gone for now. So here's what I just wrote in there. The mean is 2.0 girls. The standard deviation is 1.0 girls, and the variance is 1.0 girls squared. 1 times 1 is 1, but we do have to square the units. Now, if we take a look at our formula for the mean and then for the standard deviation and the like, I do need to note what n is. N is 4. I do need to note the value for p. I do need to note the value for q. For problems involving gender, I bring p and q with me, and you need to do that too. So at this point, I can take and multiply n times p. That's 4 times 1/2. There is the 2.0 girls again. I can take and multiply n times p times q, and then find the square root. And again, we have 1 girl. And then finally, I can square that value, or just run through n times p times q without the square root to get the variance. And we got 1 n girls squared. So at the end of the day, these two guys are exactly the same. They are identical. So there's no difference between this guy and this guy. I know people don't usually like the formulas, but I tell you, these are the ones that you want to work with for the most part. And I'll tell you why. Let me do an example from your problem set. Let me do an example. So this is going to be 5.2 number. Ooh, let's see what number. I was looking at one earlier. It seemed pretty tasty. Let me go find it. Come here. Where are we? Closer. I'm getting closer. Okay. Now, and again, let me be very, very clear. Regardless of what your book says, you're not supposed to use the formula to calculate your probabilities. You're supposed to use your calculator. So, I'm going to take a look at number 22. And I'm going to change it up just a little bit. And find the mean and the standard deviation. For number 22, we are going to randomly select 20 adults. And we know, what do we know? That 54% of adults use those smartphones in meetings. These days and ages, it's kind of maybe how you connect. So we've selected 20 adults, and we know that about 54% of all adults use their smartphones in meetings. So I want to go ahead and I want to find the mean number using those phones in those meetings. I know that n is equal to 20. I know that p is equal to 54% or 0.54. Therefore, q is equal to 46% or 0.46. So for the mean, we have literally n times p. And these calculations are simple enough that they really don't need a lot of direction. 20 times 0.54, we get 10.8. 10.8 adults. So if I take a sample of 20, on average, 10.8 of those adults will use their phones in a meeting. The standard deviation, square root of 20 times 0.54 times a 0.46, and then take the square root. I'm assuming you know how to use your square root key on your calculator. So we have 20 times 0.54 times 0.46, and I get 20.228, or sorry, 2.228, or 2.2 adults. And then the variance, literally 20 times a 0.54 times a 0.46. Ooh, that was wrong. You got to type in the numbers right. 4.968. 5.0 square adults. Are we clear on the rounding? I want to round to 1 decimal place here because we're counting adults. Those are integer values. That means I've got to look one more over here. This 6, being a 5 or bigger, means the 9 has to go up. The next number up is a 10, which means this is a 0. This becomes a becomes a 5. So there we have it. And here's why I like this. Even if we had the actual table with the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, it would make for a hella long table. So the formula, when you have a binomial distribution, the formulas for the mean and the standard deviation are really the way to go. Really, truly the way to go. So at this point now, you've really been shown everything you need to see, or everything I think you need to see to successfully do your homework in 5.2. Some of the questions are confusing though. So do reach out. I'm going to go ahead and review some of this again on Monday, I believe. There'll still be time before the quizzes need to be done. Now, let me go ahead and stop my recording.